Now, we are going to move into an era where expertise is on your fingertips and the value coming out of AI is going to be interdisciplinary.
Our guest for today is Ravi Kumar S., CEO of Cognizant.
20% of our code is written by machines. It could potentially be 50% in the next 12 months.
In this conversation, Ravi talks about Cognizant's AI blueprint and his radical views on what the technology can do.
What the Anthropic CEO said. The Anthropic CEO said, with the advent of AI, you need less number of freshers in the mix. I argued the other way around, saying we will probably have more freshers in the mix.
From vibe coding to open sourcing to India's challenges in laws and limited compute. This is an episode you do not want to miss.
Software is going to be the alchemy of every business, and every business is going to be a technology business.
Hi Ravi, very warm welcome to the morning brief. So glad you could make time.
Thank you so much. Thank you for the opportunity.
So I'll begin by quoting from Cognizant's latest annual report, in which it was said, "We believe the future of IT services will be defined by two unique opportunities: AI driving hyper productivity and automation, and embedded engineering." Let's start by sort of unpacking this sentence.
Sure, Anirban. You know what? Um, the AI opportunity in front of us, I have actually expressed it in three vectors. The first is hyperproductivity, applying AI to software development cycles and allowing AI to work alongside humans to write software code. That's the single most important use case of AI. That's the first vector. It's happening all the way from 2024, and it will progressively go. This is a technology which improves over time. It's a general purpose technology. So as it improves over time, the percentage of code written by machines is going to keep going up. In a slow market with economic uncertainty, geopolitical situation around the world, productivity is a big lever for enterprises. So that's the first vector. The second vector is integrating AI into enterprise landscapes. Rebuilding the stack, localizing the AI, customizing the AI, and integrating the AI into enterprise stacks. The third, uniquely, AI has this opportunity where this technology is not just an enabler, a tool for decision support for humans, but it can actually take over human labor and what we call is agentification. So once you integrate the AI technologies into enterprise landscapes, you can actually agentify and take human labor out. So effectively, it's a technology which can not just be a decision support tool. It can actually actionize and take over human labor. The art of the possibilities there is just immense, because not only are you going to look for human labor which exists today, you're also going to look for human labor which doesn't exist today. You have to reimagine new labor pools which don't exist today. So that's the first part which I spoke about in my annual report. The second part of what we are talking about is software is embedded into everything. In the last 50 years, tech services companies enabled technology for enterprises. We built systems, we enabled process, and we made enterprises efficient as they scaled globally. I mean, we all lived in a era of peaceful globalization, if I may. And these 50 years, technology helped enterprises scale efficiently. The next 25 years is actually going to be about embedding technology into every core product and service, irrespective of the industry vertical. So the flip for tech services companies is to go from being a cost enabler for enterprises to being a new revenue generator, to actually help build new products, new services. Software is going to be the alchemy of every business, and we will actually end up going from servicing the non-core of enterprises to servicing the core of enterprises. Every business is going to be a software business. Every technology, every business is going to be a technology business. So these are the two big opportunities for tech services companies. One is embracing AI for productivity and innovation, and the second is embedding software into everything we consume, be it services or be it products.
Understood. Ravi, so clearly, I mean, it's way beyond what people had thought, or some people still think of it as just incremental automation, right?
Yeah. So, Anirban, we are the only company which audited the number of lines of code written by AI, and in our earnings for the last 2 quarters, we have mentioned that 20% of our code is written by machines.
Correct.
Now, interestingly, that 20% I'm talking about, and this is my view as a practitioner, it could potentially be 50% in the next 12 months.
12 months. Wow.
Now, yeah, I mean, already enterprises are quoting that they're doing to 50%. I mean, if it is new code written, there's no legacy attached, the estate is clean, you could potentially do 50% even today. But in the next 12 months, at an aggregate level, you would probably get to 50% code. Now, the argument is, if so much code is written by machines, what happens to the human endeavor?
Of course. Of
I
course.
mean, look, I have a strong belief that technology has elasticity. There are only 25 million developers around the world, software developers around the world. The world needs more. If you apply the Jivan's paradox, I mean, Jivan's paradox is an economist who wrote about working under constraints. If you apply that theory, when you do more for less, you will end up doing more, and the elasticity to consume is actually going to increase. There is so much software needed in enterprises and industries across the world. So our belief is, if you pivot this well, you could actually improve productivity for developers and get a lot done for less. Remember, over the last maybe 15 or 20 years, the cost of capital was very low. In the developed markets, the cost of capital was 2%.
Mm.
With the cost of capital being so low, the discretionary spend for technology was much higher because it kind of crossed the hurdle for business cases. Right now, the cost of technology has gone up, which means the cost of technology deployment has to go down so that you have the same velocity or more velocity of technology to be consumed by enterprises. To me, this is a game changer because if you genuinely believe this can be done in a way that developers actually use these platforms and improve the throughput, then you could actually generate a lot more throughput for the same input.
Got it.
And that's what we are doing at Cognizant. We are actually making sure that developers use this efficiently. In fact, the people we hire from schools, we do 25, 30,000 a year.
Mm.
We don't want them to even know about the classical way of writing code. We want them to think about writing code has only is only done alongside AI algorithms. So that's the only way they will look at it. So they leapfrog directly into the future.
Mhm.
And that's what we're doing in our boot camps when we hire from schools. That we're
Right.
telling them there's no other way to write code. This is the only way to write code.
Mm, mm,
But
mm.
Anirban, uh, in the recent times, we have started to reflect on this issue. If the future of software software is about agentification. Are we going to be thinking about software development cycles, or are we going to be thinking about agent development life cycles?
Right.
And there is a huge difference between SDLC and ADLC, as I call it. Software development cycles go through requirement gathering, design, development, deployment, and maintenance. And if you look at agent development cycles, in lieu of requirements, you will probably have to do outcomes. What I mean by that is in SDLC, everything is built around requirements. In agent development, it starts with outcomes. So instead of scoping for a static set of rules, you're looking at good behavior by an agent. The second aspect is process design. Process design is going to flip to behavior design. What you do in a SDLC is you look at a series of predictable steps and you code against a well-defined spec,
Hmm.
and you kind of validate whether the code written is in line with your requirements.
Got it.
In a agent model, you are literally shaping agent behavior. What that means is you are identifying context, you are controlling the flows and decision making.
Hmm.
In development, what we do in the traditional SDLC, in the agent development cycles, you're looking at ways to scale through component libraries. In testing, it's a very important phase. We write test cases, we check it off a UAT list. But with agents, you are looking at behavior in the real world, and you're kind of validating whether that behavior is good enough, and you're applying guardrails whether you could trust that behavior.
Hmm.
So many things are going to change when you do agents development. We want to go through a completely different paradigm, if I
Hmm.
may,
Hmm.
to to get there.
Right.
And that is the power of what we believe the future of software is going to be.
Just to bring you back, and you started with the fact that 20% of code written in Q4 by Cognizant developers was AI generated. But here's some other data. Your data shows a 37% productivity uplift among the bottom 50% of developers with AI tools. You've trained to 30,000 people in AI and 168,000 in Gen AI. Now, I wanted to understand just the human aspect of it. And with vibe coding, correct me if I'm wrong, if it in the simplest of terms, if it means that people who cannot code, non-coders will code now. So how do you balance upskilling speed with deep expertise and avoiding creating an AI literate but a shallow workforce?
Yeah, that's a great point. So first of all, Anirban, I've written multiple articles about how AI is going to be an equalizer. What I meant by that was the bottom 50 percentile actually get more productivity than the top 50 percentile. What does that mean? What that means is you're uplifting the bottom, and you are also uplifting the top. So you're taking the whole thing a notch above, and you're compressing the upper limit to the lower limit. By making this change, you are allowing the developers who actually are at the bottom to actually get significantly more productivity. So here is what it might mean. What it means is entry barriers to these jobs are going to shrink. You're going to find more number of people accessing software development cycles,
Basically, narrowing the skill gap, right?
narrowing the skill gap. You're going to reduce the gap within an occupation and the gap between occupations. You're going to actually create more diversity in a developer profile. In the past, most developers were technology, computer science, and engineering backgrounds. You're going to now find non-STEM disciplines being a part of software development cycles.
Sure.
What does that mean? If non-STEM disciplines become a part of software development cycles, you're going to find more diversity in problems solved. And the human endeavor since the Industrial Revolution has all been about solving problems. The human endeavor has to equally pivot to finding the next purposeful problem. So, embedding problem finding as a part of your work and not just solving problems as a part of your work while you share the load of solving problems with machines, I think is a very important switch in here is what has happened over the years. Because humans spend a lot of time on validation, they spend very little time on creativity. If you are sharing that load of validation with machines, repetitive tasks with machines, you are actually going to create more bandwidth for creativity, more
Mm,
bandwidth for finding problems.
right.
And if that happens, I think we're going to find our workplaces to be much more purposeful.
Right. I have two very basic questions for you, just to maybe you'll have to sum up what you've already said. I'm First part is curiosity. What happens to STEM in the future? And 2-3 years down the line, what will a developer in Cognizant look like?
You know, Anirban, it's a great question. STEM skills are still needed for deep programming. I mean, writing AI algorithms, which thereafter will write code, will still be written by computer science engineers.
Hmm.
So I have a strong belief that STEM skills on one side will do deep programming, and non-STEM skills will create more diversity in the code we write and the diversity in the problems we solve using software and technology. Now, the most important change in this new world is going to be interdisciplinary skills. Um, Look at what has happened. So far, we have given a huge premium for expertise, for deep expertise, for deep specialization. And the era we've all lived in is about super specialization. And that's because as you penetrate more into a discipline, you actually get more value out of it. Now, we are going to move into an era where expertise is on your fingertips. And if expertise is on your fingertips, and the value coming out of AI is going to be interdisciplinary at the intersection of technology, industry, domain, and operations, you're going to give more premium to interdisciplinary skills. So I'll give you an example. If you're a history major, today the way to generate value if you're a history major is to go deep into history. The second way of generating value, if you are able to support your endeavor with AI tooling around you, is to create interdisciplinary skills at the intersection of history and computing sciences. Or, if you have the ability to uh, use the power of AI to use it in history. If you do so, what will then happen is you'll actually become a futurist because you would take the past and predict the future using the power of technology. Let's look at drug development cycles. Drug development cycles are, they're longish because a lot of human effort goes into drug development
Right.
cycles.
Right.
If you're a biology major or a chemistry major and you have skills related to AI and you have skills at that intersection, you can shrink the development cycles, the drug development cycles. So the point I'm making is universities, academia are used to giving a premium to deep expertise and to specialization. I think we're going to find a new swim lane of interdisciplinary skills.
Hmm.
I have a 3-year old and a 5-year old at my home. If I have to tell them how should they equip themselves for the future, I'll tell them two things. In your K-12 education, be a lifelong learner because the life of skills is very short. If you're a lifelong learner, you can learn, unlearn, and relearn. And life of skills are very short. People are working longer, they're living longer. So you should be a lifelong learner in K-12 school. The second thing I would tell them is build capability at the intersection of a domain and a technology. You could be studying music, you could be studying history, you could be studying anthropology, psychology. It doesn't matter. But with technology as an intersection, you will have a very powerful impact to the world in comparison to just being a specialist or a super specialist in the process. And that's why, if you remember, one of the articles I wrote in recent times, and it's a contrarian article to what the Anthropic CEO said. The Anthropic CEO said, with the advent of AI, you need less number of freshers in the mix. I argued the other way around, saying we will probably have more freshers in the mix. So you will need more freshers in the mix because you could actually leapfrog to specialization much faster with the use of technology and having expertise on your fingertips. Digital technologies gave us information on our fingertips. AI is going to give expertise on our fingertips. So I actually argue that you could actually use more freshers and create a much bigger pyramid in our workforce in comparison to the past because of the leverage of AI.
Right. And yet, in the short term, I think it's the freshers that are getting the boot from
I mean, in the
companies which
short
are.
term, look, it's a S curve. Um, we will see a hockey stick of adoption of technology.
Mm.
If software engineers at the bottom of the pyramid are smart enough to use the tooling, they will actually get the productivity. And if they get the productivity, the consumption of software, the consumption of technology will go up. And as that happens, more freshers will be needed in the mix. That's how I see it. I mean, it's a temporary blip as a lot of software is in combination of machines and people. But as that happens, more technology will be consumed, and as that happens, more people are going to go into the workforce.
Got it. Coming to the agent bit, and also I'd like to shift the conversation a little to your open sourcing initiatives, and Cognizant is clearly ahead of peers in this. So Neuro is an example. By open sourcing Neuro, you have taken a very bold stance on shared innovation. Now, just connecting that, and please correct me if my connection is wrong, but just connecting that with the future, which is multi agent systems. How do you see that shaping the future of what is now team based coding and enterprise based problem solving?
Anirban, uh, 3 weeks ago we open sourced our multi-agent neuro platform, and the thesis was very simple. As we were taking this to clients, and our clients were loving it. I mean, look at what's happening now. Agent ecosystems are getting built on top of the existing software. So you
Right.
have Salesforce agents, Workday agents,
Mm.
SAP agents in a enterprise setup. Problems are solved when these agents come together because the workflows actually span across these ecosystems. So we built a multi-agent orchestration layer early on in 2024, and we felt like that is a great way of supporting the agentification process and supporting the agentification process of existing software companies. And then we realized that two things are important for us. One is clients have to see the neutrality of that orchestration layer we were building. So the best way to make the clients not get stuck with a provider but stuck with a technology
Mm.
which will shape their future. We thought open sourcing is a great idea. The second reason why we felt open sourcing is important, Anirban, is when the technology is evolving, more people have to contribute to the development of the technology. So if you're open sourcing it, you will then have, the academia, developer communities outside of Cognizant, our client developer communities, all of them contributing to the process of open sourcing. Now, you could argue and say, how would you commercialize it then if you open
Correct.
source it?
Correct. Yeah.
The way to commercialize it is to build the necessary enterprise guardrails which come in a controlled way from companies like ours. Because if we open sourced it first, we have the expertise and we have, we have the acquaintance of the stack with us. So essentially, open sourcing happens in a very liberated way. And when you bring it to an enterprise landscape, you have to build those guardrails around it so that it has the controls and it has the necessary security and the necessary responsible. It has the responsible. It has the safety and the responsibility imperatives needed for a technology in an enterprise landscape. So we stitch all of those things together and we make money on the services.
Right.
So we are a services company. We want to make money on the services and we want to use the IP to accelerate the services and create a flywheel around it.
Got it.
That has been our endeavor and that's why we open sourced it.
Right. In a related context, um, uh, one AI is co-creating IP and code, and over there, of course, there is this whole open sourcing that is happening. How is Cognizant rethinking, say, ownership, questions of accountability, of ethical authorship? When you have client engagements.
It's very clear, irrespective of whether it is human labor or digital labor. I mean, what I mean by digital labor is agents. If the systems are owned and managed by Cognizant, we have accountability to the outcomes related to it. It's the same when you're using it as a consumer. If you're using it as a consumer, say if you're applying for a mortgage at a bank, and an agent is deciding on the behalf of the bank to give you the mortgage or to reject the mortgage,
Hmm.
then the bank is accountable for the technology they've deployed, and they can't actually say that it's not us, it's the agent. The agent belongs to you. I mean, like employees belong to you. So you have to look at it in a broader context that responsibility actually comes for both digital and for physical labor.
Hmm.
Most use cases today which are getting generated have human in the loop, and therefore there is
Right.
accountability to the process. And the human in the loop is really the validation process for you to accept that outcome. Equally, Anirban, what's also happening is most AI generated output, be it agentified or be it used by humans, uh, has explainability guardrails.
Hmm.
I mean, I'll tell you what that is. When the algorithms underneath your underneath your systems are deterministic in nature, then there are a set of rules which determine the output.
Sure.
When humans decide and give you a decision, you're going to ask the human, why did you decide this?
Hmm.
And then humans give you the rationale behind why they decided what they decided. And then then that becomes the safety net for you to accept that output. Now, when the output is probabilistic, which is in case of neural networks
Right.
and generative AI based models, uh, you need explainability behind it because the output is not generated with a set of rules. It is
Mm,
generated on a neural network.
mm,
So a lot of times, most of our use cases actually have explainability as a part of the mechanism. In fact, at Cognizant, our neuro platform actually has the explainability piece. So we literally, bolt on that functionality
mm.
when you are applying a use case into production. So that if a end user says, "Wait a minute, how did I get this? How did the machine decide this output?" You then go to the explainability section, and in natural language, you will see how the machine decided on the output. So that's actually an integral part of regulation today. I mean, regulators are asking that question: human in the loop, explainability, guardrails. In fact, we have in our labs, we have a research going on, what we call that as semantic density. And the research, it's a patented research from Cognizant. What we essentially do is um, we have uncertainty guardrails.
Okay.
So effectively, within those guardrails, the AI algorithm and the output of the AI algorithm is good enough. As you cross those guardrails, it defaults into a rule-based model because we believe the output is not as predictable. So we jump into a rule-based model. But
Got it.
remember, you could always use a rule-based model for the whole thing.
Mm,
The reason why you're using generative is to uh, is to create more machine-led output, which can be replicated um, for what humans do today. So you don't want to pull away everything a machine does creatively. Otherwise, the purpose of generative AI is lost. But you also want guardrails attached to it because you don't want it to go rogue. So it's effectively that fine balance, and therefore every time you're applying generative AI use cases in the real world, you have reasoning layers attached to it to create the necessary controls so that the output is within the limits. Even if it is hallucinating, it's within the limits.
mm, mm.
So all of these are a part of what regulators look for, what implementers like us look for to make um, to make those use cases real in spite of a probabilistic model underneath it.
Right. Two final questions. One on use cases of agentic AI. A very, two very basic questions actually. So, you mentioned Salesforce, and both Mark and Arundhati are extremely positive about what use cases there can be in India on agentic AI. In fact, in a recent interview, Arundhati told us about how it can be used in agriculture, for instance. You mentioned pharma and other whom we also interviewed recently seems to be very excited about how drug trials will be so much faster when they are done through the AI route. Can you tell me about some more use cases that you see happening in India through agentic AI in the next 2 3 years?
Absolutely. If I take a broad categorization, Anirban, tech for tech is the biggest. We spoke about writing code, software development cycles, agent
Mm,
development cycles. That's the biggest use case.
mm,
A large number of projects are in that space. The second, I would believe, is content aggregation. Wherever you want to aggregate content. In fact, content aggregation was a big use case for AI even before generative AI came into picture.
mm.
The third, I mean, this is probably the single biggest use case I'm seeing, is customer care and employee care. Customer care and employee care are the third biggest use case. I mean, a lot of things like onboarding employees, knowledge management, recruiting, customer care. I mean, I'll give you an example. We just signed a deal with a large company recently where we took over 500 of their customer care agents, and we are preparing a model of 65% AI agents and 35% human agents as the end state of the customer care for that enterprise.
Mm.
And of course, the 500 people we've taken over, we will redeploy 65% of them because you have AI agents in the mix. And our endeavor is we train them to work alongside AI agents, and therefore we can actually distribute that capacity to more clients. I would say in the future, the most you're going to see is about content generation. It's the most difficult use case, but it is the smallest number of use cases today. But as this technology evolves, you're going to see the most of it. But Anirban, I'll tell you what, the
Mm.
excitement I have is we are lining up in the third week of July to
Absolutely.
host the largest vibe coding event on the planet. Um, we are getting 350,000 of our employees. I'm hoping more than 200,000 log in there. You write code, you don't know how to write code, you're a marketer,
Right.
you're a journalist, you could just come in and express yourself. In some ways, the vibe coding term is a misnomer because vibe coding might kind of appears like you can't do serious coding on it. It's a vibe thing. You have to do fun stuff and experimental stuff. I don't believe in it. I actually have a contrarian view to it. Just because coding is open to everybody and
Mm.
it can be, you could write code even if you're not a coder, doesn't mean coding is not a serious act. Coding is a serious profession. So we think with the power of all this AI tooling and the code assist platforms, which we are going to demonstrate, we will uh, we will make that the only way
Absolutely.
of writing code in Cognizant.
Mm.
And once we are done with that, we will then, if we have this big vibe coding event in July, subsequently we're going to create one where we will invite universities and colleges in India to participate in a big vibe coding event, which is beyond the Cognizant ecosystem.
I love how natural language is becoming coding language, and I feel very tempted to try it myself. I mean, obviously, I use the Chat GPTs of the world, but even coding, perhaps someday. But I'll end with a question on challenges. And you spoke about regulations and what regulators think when they are thinking AI. But I think there is a gross lack of data laws in India. The other challenge is that we don't have enough compute. So, how can India have an AI revolution that it's planning, or that it's envisaging, without enough compute on one hand, and lack of data rules or data ownership laws on the other?
Anirban, first of all, there are multiple aspects to AI revolution. There is talent and the ability of expressing, the ability of expressing yourself in a very creative way. That whole piece, India is really top notch, and there's no country on the planet which has as much talent and technology as India has. Second, India is also becoming the office of the world. In the next 10 years, India is going to house a lot of operations of enterprises. It's not just technology, because that's where you're going to apply AI. So India is probably going to become the home for operations and technology to come together. Third, India by itself has population grade data because India is the only country which has a digital stack which is population grade. So data is available at population grade in a very micro way across transactions. So India can actually be, I mean, data is the fuel for AI. It kind of feeds the AI in a way that you could create efficient models. Fourth, India is also one of those countries which is known for frugal innovation. I call it reverse innovation. So the ability, I mean, the challenge with AI is how do you make it cost viable? The cost of compute is expensive, the cost of data is expensive, building a model is expensive. How do you make it viable for better consumption? So, with the reverse innovation and the frugal innovation techniques India applies, it can actually flourish. What it does need to solve is the sovereign data imperatives, the requirements of compute, and the lack of compute available locally, and of course the ability to create governance and regulatory framework. These are the three things India has to work on, but just the number of things it has, these three things will become an enabler and not a constraint, because I mean, whenever you find the opportunity ahead of you, you're going to break the constraints to get there, and that's what India, I'm quite confident, would do.
On that note, Ravi, thank you so much for joining us on the morning brief. This was a wonderful conversation.
Thank you, Anirban. Thank you for the opportunity to talk to you and your audience.